Afternoon everyone. So here with me we are going to do approximation and estimation under mathematics. How are you supposed to tackle such questions? So we have been taught to say the first question says the mass M of a bag of milling meal is 25 kg. Complete the statement below. So we have this statement, we have the mass. Question 2 says the mass M of a block of wood is 876.4 grams. Correct? One decimal place, complete the statement. We still have that. Then B says that the length of the piece of wire is 15.2. Correct? One decimal place, the relative area of the length. So our solution. So we have the length. We have been given the mass for the first one. So we have 25 kg. Now we are told to say complete the statement. So how do we complete such a statement? The first thing is that if, let's say, a milling company is making milling, they will be making, let's say, a 25 kg bag. Now, this 25 kg bag, due to human error, sometimes someone might measure something that is less or more than 25 kg. So now, there should be a upper limit. So if you are measuring, let's say, 25 kg, you don't expect someone to go as high as 30 kg. That would not be profitable. So therefore, there is the upper and the lower limit. So this is what the question asks us to find. So in order for us to answer this one, we need to find the lower limit, the lowest, upon which the mass, which is 25, should be at least the minimum. So the minimum, so how are we going to find that? So first we have been taught to say it's 25 kg, a 25 kg bag. So if you have any number without a decimal point, what we are going to say is, if you have 25, the minimum number that can be measured is 1 because it does not have a decimal point. So you begin counting from 1, 2, 3 until 25. So we have 1. Then this the lowest division, we are going to divide by 2. Then we are going to have 0.5. So this, in fact, is what we call the absolute error. So anyone working at, let's say, a milling company is exempted to, or can be understood if they make the error of 0.5. So you get the minimum unit that can be measured, which is 1, if we are considering a number without a decimal point. So we have 0.5. So what we are going to do is, we are going to find what we call the lower limit. So the lower limit is simply the same mass minus 0.5. We also have the upper limit. The upper limit should be equal to the same mass. We add this time 0.5, the same one. So if we have this mass, we have a 25 kg. We add plus, or we subtract 0.5. We are going to get a 24.5 kg. If we add this to make the upper limit, we are going to have 25 plus 0.5. So if we add this, we have a 25.5 kg. So this 25.5 kg is actually what we call the upper limit, the maximum limit that someone is supposed to make as a mistake. So we are going to now fill in. So we have mass. Here we have should be less than or equal to m. So the one that is less than or equal to 25 is this. So on the first part, you are going to put 24.5 kg. Then, and also here we have the upper limit, the maximum, we have a 25.5 kg. So this is how we answer such a question. Now looking at question 2, the mass M of the block of wood is 876 grams. Correct to one decimal place, complete the statement. Here we are going to do the same. Now the only difference is that here we have a decimal point. So if we have a decimal point, take notes to say the simplest or the smallest division that can be measured is, since we have a decimal point, it's 0.1. So here we are going to say absolute error so the minimum error or the minimum division that can be made, that if we have a decimal point number, it's 0.1. Then we divide by 2. We always divide by a 2. So we have 0.05. So this is what we call our absolute error. Now to answer that, we are now going to add to find the lower limit and subtract to find the upper limit. So we have the upper limit. Upper limit should be equal to, we have the number 876.4. We add 0.05. So when we add, we have 876.45 grams. Then, if we look at the other one, we have the lower limit. So to find the lower limit, we are simply going to subtract. So we have 876.4 minus 0.05. So when we subtract this, we are getting so when we subtract this, we have a 5, we have a 3, we have a 6, 7, 8. So when we subtract this to get the lower limit, we are getting this number. Now, we are getting this number. We have been told to say correct to one decimal place. So to correct this to one decimal place, it means to say here there is a 4 or there is a 5, so we are going to add 1. So the upper limit should be 876 point. When we add 1, we have the 5 here. Then there, when we add 1, it's 876.4 grams. So to complete our statement, we are going to do the same. The mass here, less or equal to, the lower limit should be 876.4 grams. Then the upper limit should be 876.5. The last but not the least, we have the length of the piece of wire is 15.2, corrects to one decimal place the relative error of the length. So the relative error, which is simplified as RE, should be equal to absolute over the true value. So how do we find the absolute error? So the absolute error, as for a number that is that has got a decimal point, always remember to say the absolute error, allow me to put it here, absolute error as AE should be equal to, we have 0.1, since there is a decimal point, divided by 2. So we are getting a 0.05. So now, remember, our relative error, simplified as RE, should be equal to absolute error over the true value. So our RE should be equal to our absolute error 0.05 over, we have the true value. So our true value is equal to 15.2, of which we can go further by multiplying 100 and here 100, so that we have this decimal point moves twice, so we have 5 over 1,520. When we simplify this, we are going to have 1 over, here we have a 3, we have 0, 4. So this is our answer. So that is how we go about answering this type of approximation and estimation. Thank you very much for watching, and I hope you subscribe, like, and follow for more.